let's fit our first logistic regression model. We need to import our data. It's the 7 mortgage data. Change its name to mortgage and run to import our data. Now under tasks and utilities, tasks, linear models, we're going to select binary logistic regression. It's our first time using this. Make sure that we've got our correct data selected. And now we've got a couple of, we've got something new that we need to select here in our roles for all of our variables. Our response variable is what we call our dependent variable in logistic regression. So that's our approved variable. And then we have to tell SAS Studio which of the levels of approved is a success in our data. So we can choose either 0 or 1. 0 is the loan being rejected, 1 is the loan being approved. So an approval is what I would think of as a success here. That's what I'm trying to estimate the probability of. So I'll select 1 as my event of interest. You could change this link function if you wanted, or to change the particular model that was being built. What this is going to do is change the shape of the curve that fits the data. You can play around with that if you want. I'm just going to leave it at Logit. In my experience, Logit and Probit always give very, very similar answers. The complementary log does a couple of weird things that I'm not super comfortable with. So we're just going to stick with Probit here. We don't have a classification variable, we've just got one other variable, the credit score. So we'll put that in. Under model, we could just leave this as main effects model. This is going to enter the continuous variable just by itself. It's not going to create a polynomial from it or anything like that. You could do that if you wanted using a custom model. You could also choose to include interactions using the custom model, or potentially using the shortcut main effect and all n-way interactions. And I think we need one more thing. Under options, change default plots to all plots, and let's run. Now this does take a couple of seconds to run. Logistic regression is not the fastest thing in the world, but it shouldn't be too terrible. Okay, so here's our results. We had 362 people approved, 638 rejected. This is from the actual data. We've got our test of the, our global test for the model. This is like the global F test, the test for overall validity of the model. So we should expect here to see a p-value less than 0.05, and we do. In logistic regression, there's at least 3 different ways that you can do this global test sensibly. They're all pretty much going to give the same result, just like they did here. So you don't really need to worry about this too much. Our model is down here. This is our parameter estimate for credit score that describes how an increase in credit score will increase the chance of approval. I'll describe that a little bit more in the text on Blackboard. But what we really need to pay attention to is 2 things. One, is it significant? Yes, p-value much less than 5%, so we're good to go ahead and interpret this. And it's positive, telling us that as credit score goes up, our chance of approval goes up, which makes sense. The last thing I'm going to show you, scrolling down to the bottom here, is our graph of predicted probabilities. So this shows us for each for each credit score on the x-axis what the probability of acceptance is on the y-axis. And again, I'll go into that in more detail in the text.